All right, grab your magnifying glass because today we're playing detective. Welcome back to the Explainer. Today we're diving into a really cool, hands-on scenario straight out of the DP-300 Database Administrator playbook. We're going to hunt down a database performance bottleneck in Azure. But, we aren't just going to look for it. We're actually going to build the trap, spring it ourselves, and then use some very specific Azure Portal tools to track it down. So let's dive right into this.
First things first, here is your official assignment. Quoting straight from our source material here, you have been hired as a database administrator to identify performance-related issues and provide viable solutions to resolve any issues found. So, that's your roleplay mission today. You're the lead DBA, and you're stepping onto a digital crime scene of spiking CPUs. Your main tool? The Azure Portal. Your objective? Figure out exactly what is choking the system, and more importantly, why.
Okay, Section 1, Mission Setup. Let's get our Azure environment prepared. Now, before we can solve the crime, we kind of need a crime scene, right? To get the lab files, you'll need to pull them down. Just open up Visual Studio Code, fire up the command palette, and clone the official Microsoft DP-300 Database Administrator GitHub repository. You'll definitely want to save this right into a local lab files folder. Doing this gives us all the deployment scripts we need to spin up our virtual environment in literally just a matter of minutes. Once you have those files, the setup is incredibly straightforward. Step 1, you just open up the VS Code integrated terminal. Step 2, run the as-login command to authenticate with your Azure credentials. And step 3, you execute the deployment PowerShell script. By default, this brilliantly illustrates the power of automation. It quickly provisions a resource group, sets up a SQL server in the West US2 region, configures the database, and actually, it even automatically adds your public IP address to the SQL Server firewall rules. Just like that, our testing ground is live.
Moving on to Section 2, the trap. Let's review our CPU utilization.
Okay, so our database is up and running. Now it's time to deliberately sabotage it so we can test out our monitoring tools. To set this trap, you'll navigate over to the Azure portal, search for your newly created SQL server, and head right into the AdventureWorks LT database settings. From the left navigation menu, just fire up the query editor. You log in using those SQL admin credentials generated during your setup script, and boom, you are inside the database, ready to execute some code.
And here is our primary suspect. Really notice the structure of this T-SQL query we're dropping into the editor. It isn't just your standard select statement pulling some customer addresses. Notice that wrapper around it? We're setting a counter and initiating a while loop. While @counter is less than or equal to 10,000, we are actively forcing the database to run this exact same customer address lookup 10,000 times in a row.
But we aren't stopping there. The source instructions tell us to run this query, wait for it to complete, and then rerun it 2 more times. 10,000 loops run 3 separate times. That is 30,000 executions of this query. We are aggressively and intentionally spiking the database's CPU load to create a massive, undeniable bottleneck.
So, to verify our little sabotage actually worked, we head over to the metrics icon in the monitoring section of our database blade. We change the metric over to CPU percentage and set the aggregation to average. And right there at the very end of the timeline, you'll see it. A massive, glaring spike in CPU utilization right exactly when our looping query was firing off 30,000 times. The crime has officially been committed. Now we put our DBA hat back on to investigate.
Which brings us to Section 3, the investigation, identifying those high CPU queries.
We clearly know the CPU spiked, but we need to find out exactly which query caused it. Our main magnifying glass for this particular case is Query Performance Insight, which you'll find in the Intelligent Performance section. When you open it up and review the grid down below the graph, your culprit is going to appear. You select the query, and it offers up a really rich amount of information. It confirms exactly what we expect, a total duration of over a minute, and it clearly logs that the query ran roughly 30,000 times. Seems like an open and check case, right? Well, because here is the major plot twist of this explainer. When you review the SQL text on the query details page against the exact query you literally just ran, part of it is missing. The query details only show the select statement. It completely, totally hides the while loop. The very mechanism that caused our CPU spike, the loop itself, is completely invisible to the Query Performance Insight tool. So why does that happen?
Well, the crucial point here is understanding how this tool actually works under the hood. Query Performance Insight doesn't just magically see every single thing, it relies entirely on data fed to it from the query store. In the query store, it has a very specific blind spot. It strictly tracks data manipulation language, or DML. It completely ignores data definition language, DDL, and control flow statements like our while loop. To be super precise, whenever you are conducting your own future performance investigations, just remember this rule. Query Store is going to capture your select, insert, update, delete, merge, and bulk insert statements. That's your DML. If your performance issue is being caused by thousands of loops wrapping around a basic select statement, Query Performance Insight is only going to show you the select. It tells you it ran 30,000 times, sure, but it won't show you the while loop script that triggered it. You just have to be a good enough detective to connect those dots yourself. All right, Section 4, Mission Accomplished. Let's talk about cleaning up your resources.
Case closed. You successfully isolated the problem and learned some really vital limitations of your monitoring tools. But, as we know, a good DBA's job isn't done until the workspace is clean. If you aren't using this Azure SQL Server for anything else, you absolutely must tear it down. Leaving idle resources running in a cloud lab environment is a rookie mistake, and it can definitely lead to some unwanted Azure billing.
Depending on how you actually set up your lab, you have 3 distinct deletion options to completely sanitize your testing environment. If you created a dedicated resource group just for this lab, easy, simply delete the entire resource group right from the portal. If you shared a resource group, you'll need to go in and delete only the specific resources prefixed with your lab's SQL Server name. And finally, don't forget your local machine. Head over to your C drive and delete that lab files folder you cloned from GitHub earlier.
And honestly, that brilliantly illustrates how to effectively use and understand the limits of Azure's Query Performance Insight. But I want to leave you with a final thought to chew on today. If a massive while loop can be completely stripped from the query text in your primary monitoring tools, what other invisible bottlenecks are hiding behind untracked control flow and DDL in your production databases right now? Keep honing those detective skills, and I'll see you in the next explainer.
Section of lab, I'll go through DP-300 Database Administrator, and lab is number 6, that isolate performance problems through monitoring. So as a database administrator, there are performance issues that you need to identify and provide a viable solutions to resolve the issues. So this to resolve those issues, we will go through Microsoft Azure Portal. I'll share this GitHub link so that you can follow into your own lab environment. Uh, Let me move this side. Okay, before that, make sure that when you go through, you downloaded from this Git repository where all the lab files are sitting there. So I have already downloaded those lab files, and then from there, I'm going to open that in a terminal window. Let me zoom in and do full screen. I can do little smaller. Okay. Now from here, let me log in or connect to Azure through Azure CLI. So press enter. So you can see that a browser window will open for logging in. So here use your Azure credential. Pass the ID password. So you can pass token, otherwise you can select this one to pass password. Click sign in. So it's registering the device. Then you can see that account added to this device. So click done. Now you can see that it retrieved tenants and subscription informations. If you're fine with that one, then you just press enter. And otherwise you should type a number or enter for no change. So press enter. So now when you get the prompt, let's go to and execute the script. So change directory to setup and execute the deploy SQL database. So that is PowerShell script. It has got when you download it, you can just press that one. Just make sure that you have the right resource group. Otherwise, you need to create resource group beforehand. You can go through the lab information to get more info on that. Deployment completed. It's just message unexpected at this time. So this is we can ignore for this lab purpose. Now let's go to the portal. And we can see the information like resource group name, SQL server name, and it's giving like password information. So here, let's go to portal. So give them password informations. And if you go to the resource group, we can see which this under this resource group. If we click that one, we can see which resources are provisions. So by that PowerShell script, it provisions a SQL server and SQL database that we can see it from here. Collapse this one. Now select the SQL server. And if we go to under security, let's go to networking sections. And here, can see that client IP address. This is the client IP address, so which is my IP, computer IP address. And then add this one. So select add your client IP address. This coming. Like check that exceptions and click save button. Now go to settings section. And from here select that SQL databases. And then select this database. And now here you can see that currently we have this database, and if you go through, then you can see that there are different options available. Getting started, then monitoring, notifications, and also if you see left side, then you can see that query editor preview options. So select that one. And preview means it's showing that it's in preview options. Now here you can see that Microsoft Intra authentications for query editor. You can select either Intra, otherwise authentications. So in our case, let's select that SQL authentication, and here giving the username, and you can see that it has got this like database name. This has got the on that lab section, and you can just give the password information here and click connect. And in this screen, you can see that there's a query options, and you can see those adventure works. There are databases, DBO, like default one, uh, informations, then also this sales LT. But here is a new query. Select that one. Close this window. Now type the SQL here. Now you can execute that one by click that run button. And down below you can see that it executing. We have executed, so we will run again few times so that it generate some kind of CPU load on the database, which we would like to monitor that one. So let me execute again. So it completed. You can see that down below it's succeeded. So let me execute again. And here you can see that 5 columns and also 450 rows. And if you execute the same query again and again, it will be get that from the memory, so it will be run faster than the previous run if you don't reboot that server. So this time it runs 21 seconds, 356 milliseconds. So if you run again, so less than that. So we have run few times. Now let's go to monitoring sections and go to that alert section under monitoring. Select that one. So here mainly for creating, but let me go back to this normal adventure work section, database section. Select this database. I'd like to see the generic how much information this is collecting from here. You can see that monitoring tab. If you go there, you can see the database storage wise. You can see that there is a CPU spike when you execute those jobs. Now you can see that there is options also like show data for last 1 hour. You can filter that one, and you can also filter the aggregation type, max, mean, and average options. If I average, you can see the value here. Now to identify high CPU queries, um, there's options that we can go to query performance. So for that, let me go to another section. Now let's go back to identify high CPU queries. So you see that intelligent performance, expand that one. And there you can see that performance recommendation also there, also performance overview. But let's go to query performance insight because we'd like to see the query wise. And here you can see that option is there, reset settings. You can go there and down below you can see the queries that we executed. Normally you will get see this here. So let me open this one, query ID. As you can see that some query ID there. So under that query details section, you can see that it's giving select statement to execute it. So normally this section so hold, select, insert, update, delete, merge, bulk insert, like all the DML commands here or DDL commands. You can see that one. You can see for like CPU informations used by the query. Then you can see how much time it spends. Also execute count. and you can see the recommendation sections. If there is any recommendation, you'll get that options here available. But we need to make sure like high CPU does not mean that there are some issues, because there can be some SQL for the business or application perspective which can take that high CPU. That can be for a specific time window, or maybe single query once runs in a week. It can do that one. So this is the way that you can work on performance by going to Azure Portal. Uh, so it's always recommended, or to avoid your incur cost from your um, like lab environment. It is always recommended, or good practice, to delete the resource group. So go to the resource group and then delete that resource group. So if you have any questions, please add that into comment section. Please subscribe to my channel, and thank you. Thanks for watching.